This video is for those of you who want to understand functions. So in this tutorial, we are going to talk about functions in general, but specifically we are going to talk about how to find the domain and range of the linear function, how to find the domain and range of radical function, the domain and range of rational function, and many different functions. And we'll go further and also talk about quadratic functions, where we are going to be able to sketch the quadratic functions. We should be able to know how to find the minimum and the maximum point. And at the same point, we should also know how to find or how to know if the function is one-to-one. At the same time, we should also be able to know the odd and even function. So let's begin our discussion with this first question, which is saying the function f is given by f of x is equal to x squared plus ax plus b, where a and b are real numbers. If f of 1 is equal to negative 3 and f of negative 2 is equal to negative 6, find the values of a and b. What does it mean? So they are telling us to say, if at all in this function we plug in 1 where there is x, the answer we have to get is negative 3. So now we are saying that f of 1 of this, if we plug in 1 here, where there is x we plug in 1, the answer should be what? Negative 3. That's what we've been told. So I'll say negative 3. Ignore this part. So I'll get rid of it. That's what it means. So 1 squared is 1 plus a plus b should be equal to negative 3. If I shift 1 to the other side, it will be a plus b is equal to negative 3 minus 1. So a plus b is equal to negative 4. Now I want to find the value of a and b. So if I've got two unknown variables, I need another function. That's why if we continue here, they're saying that if you plug in negative 2 where there's x, the answer is negative 6. I'll go ahead and do the same thing that I've done here. Where there's x, let's put negative 2. We square it. A, I put negative 2 plus b, the answer is negative 6. Negative 2 squared is 4. So this will be minus 2a plus b is equal to negative 6. So this is b. So then if I shift 4 to the other side, it will be negative 2a plus b is equal to negative 6 minus 4. So it will be negative 2a plus b is equal to negative 6 minus 4 is negative 10. Now I can clearly see that this is my equation 2, this is my equation 1. Now that we have got two equations, that is going to be easy for me to find the values. So now this is a simultaneous equation. So what I'm going to do to make things simple, I'm going to make a as a subject of formula for equation 1. So this one should be equation 1. That is equation 1. Then this is equation 2. So for equation 1, let us make a. You can either make a or b as a subject of formula. So in this case, I'm going to make a as a subject of formula. So to make a as a subject of formula, I'm going to shift b to go to the other side. Okay. So then I'll say, I'm going to say a should be equal to negative 4, shift b to the other side, it will be negative b. What does it mean? This is my equation 3. In the second equation, where there is a, we put negative 4 minus b. So I'll come here and say negative 2, where there is a, we put negative 4 minus b, then plus b should be equal to negative 10. Okay, so then I can now expand. So this negative 2 times negative 4, it is positive 8, plus this is going to be plus 2b, then plus b is equal to negative 8, no, negative 10, sorry. So let's see. If we shift this other one to go to the other side, what do we expect to have? Okay, let's see. So now if we clearly see here, let us see. If we clearly see here, if I've shifted this to the other side, we are saying that we are going to have this. We have made A as a subtotal formula. After doing that, I'm now replacing where there is A here with what? With -4 minus that. So we are saying that this times this is positive 8. That is okay. Then this, since this is also negative, then we are going to say it is positive 2b. Yes. So then I'm going to shift this to go to the other side. So then it's going to be 2b. 2b plus b is 3b. 3b is equal to -10 minus 8. So 3b will be equal to -18 divided by 3 divided by 3. So 3 and 3 will cancel. Therefore b is equal to 3 into -18. It should be -6. So my value for b is basically -6. Now that I know that the b is -6, we should also be able to find a. But how can I find a? This equation, I made a as a subtotal formula. I plug in the value of b and find a. Okay, so I'll create space here. Then I'm going to say a is equal to -4 minus, where there is b we put -6. So a will be equal to -4, negative and negative plus 6. A will be equal to -4 plus 6 is 2. So the value of a is 2 and the value of b is -6. And for sure, if you want to prove this, I'll give you one thing, then you're going to prove the rest. So if I go back to my equation, which is f of x is equal to x squared plus ax plus b. Now in x, if at all I plug in what? I plug in 1. Then here I plug in 1 squared. A is 2, x is 1, then b is -6. The answer I should get is -3. Let's see. So f of 1 will be equal to 1 plus 2, then minus 6. So this is going to give me 3 minus 6, that is -3. So this is true. So the values of a and b, they are true. Again, you can prove by plugging in the value of x to be -2 and put a and b. You should be able to get -6. So try to prove that one. So that is it for question 1.
So find the range of each function for the given domain and state if a function is one-to-one or not. So in case you don't know what a one-to-one function is, I'll just give you an example. So a case where you have a domain matching up the codomain, where every element in the codomain is mapped onto one single item in the input, that is a one-to-one function. Now in a case where we may have two elements, let's say I introduce another member of a domain and then it matches to the same result. Such usually happens in a function of x squared, where you can have -1 and it's positive, giving you the same result. So that is not a one-to-one function. Okay, so try to answer the question. So the first part is f of x is x minus 2. That is for the first part. So the domain has been given to be -2 all the way up to 4. Now that is, they are included because it says less than or equal to yes. So now, if you want to answer these questions very fast, you would want to come up with a table of values. Now, for the table of values of this kind of a function we have is a linear function. Now the way a linear function behaves is this. If I was to sketch one, it would be something like this or something like that. So that already proves to say there is no possibility that you may have a linear function giving you y value of the same between two different inputs. It's not possible. So looking at this example, the other beauty about a linear function is if I just get the value here, the starting point of x and the one there, I'll be able to get the range. That's the beauty about a linear function, because it increases or reduces at the same rate. So in this case, finding the range means, in case you still don't understand what it means, finding the range means we are determining the expected values of x to be produced by such a function. So if that is my linear function, the value of y at this point and the value of y at the highest point, the values of y, that is the range. The domain are the values of x from there all the way up to that point. So we've been given the domain from -2 all the way up to, so maybe it's somewhere there, all the way up to 4. So all we just have to do is just substitute for a linear function. So the minimum we have is a -2. So -2. The highest we have is a 4. So how do we find the value of y? We substitute in the function. So if I put a -2 there, we have a -4. If I put a +4, we have a 2. So that implies that is the way that linear function is going to move. So the expected values of y will be -4 as the minimum all the way up to 2, given that domain. Alright, so we'll move to B. So of course it is 1-to-1, because whenever I draw a linear function, it's not possible that two different values of x will give you the same value of y. So they'll be unique at each point. So it's a 1-to-1 function. Okay. So another way you can prove that it is 1-to-1, there's a way you're supposed to prove a 1-to-1 function. So our function itself is f of x, excuse me, being equal to x minus 2. So we need to prove that if you were to have a function at a being equal to, let's say, c, and then you also get to have a function at b also giving you c, we don't want this to occur. We only want this to happen if they are the same, if a and b are the same, not being different numbers. Okay, so let's try that. So if I was to have f of a, my f of a, let me say, in this case a is supposed to be equal to b for that to be possible. So f of a is going to be a minus 2, f of b is going to be b minus 2. So I equate them. A minus 2 is equal to b minus 2. So therefore a is equal to b. So this only occurs, it's not possible for two different values of x to give you the same value, only if they are the same. That's the main idea of a 1-to-1 function. Hopefully you get that. So this is proof that it's a 1-to-1 function. We are on the second one now. F of x is equal to x squared. So the domain has been given to be from -3 to 3. So this is a quadratic function. I believe it's not new to you. So we can also try to see the way it's going to behave. So we've been given values like from -3. So I'm coming up with table values, and I'm also teaching you guys how you can first sketch functions. If they ask you to sketch, they do ask that. So I'll get a 0 in between and then a 3. So my expected value of y, I'll just substitute in the function. So if I put a -3 squared, it will give me a 9. 0 will give me a 0, 3 will give me a 9. So we are saying that we've got two different values of x giving us the same value. Now the other thing that we have to pay attention to is our domain in this case is not including -3 and +3, because it is not less than or equal to, it is just greater than and then less than, that's all. So what then should we do? So in this case, if you are to sketch this function, you know the way quadratic function behaves. So whenever the value of x squared, the coefficient is positive, you need to understand that it's going to be a minimum parabola. Okay? Now the minimum value this expected is going to be 0 for this function. 0, 0 give us 0, and then to continue going up. Okay, so a function where I'm able to draw a line, a horizontal line, and then it cuts the graph at 2 points is not a one-to-one function. Okay, so the expected range, the minimum value we have is 0, 0, and then it will just continue going up. Now, restricting the domain to a point where we're reaching only at 9 or at 3 would mean that it's ending maybe, let's say, somewhere there. This is -3 and this is +3. It's only ending at 9. So we can't go beyond. Now, the fact that -3 and +3 were not actually part of the domain because of just being less than without an equal or a dash down, the range will be restricted from 0 all the way up to 9. 0 is part of the range, but 9 is not, because 3 and -3 are not part of the domain. So that shows that less than 9, but 9 itself is not part of the solution set. Now, the other way, when you're looking at quadratic functions, you can just like use the formula for finding the minimum value. -b is equal to, so our b in this case is obviously 0, right? So you have 0 over whatever you're going to have, is 2 over 0, and then to get the value of y, you substitute it, also give you a 0, so it is 0, 0 in such a case. That's a minimum point. So a maximum is dependent on the values you have. But if there was no restriction on the domain, if let's say the domain was just a set of real numbers, it was going to be from 0 all the way up to positive infinity. And in such a case, without a restriction like that, the answer would just be from 0 and then positive infinity. Of course, infinity can never be part of the solution set. We are now on the third one. So first of all, I've disqualified the second one. It's not a one-to-one function. It's not a one-to-one function. Okay? So you can actually try it out. F of a is going to give us a squared, and then f of b is going to give us b squared. So we need to, so we'd have to prove that if f of a is equal to c, and then f of b is equal to c, then we should get the same result. Then actually a should be equal to b. So a squared is equal to b squared. So these are not equal, right? They are not equal. A squared is equal to b squared. They are not equal. So in this case, it is not. I showed you -3 and +3 were giving us the same result. Even just the fact that if you sketch it, if you draw a horizontal line, it's cutting the graph at 2 parts. So it is not a one-to-one function, or it is not an injective function. So a one-to-one function is also known as an injective function, for your information. Now going to the third one, where we are saying x is greater than 1. X is greater than 1. So quickly we can just like come up with a sketch fast. So the function itself is 1 over x minus 1. 1 over x, how am I writing there? X minus 1. So x, y, like a table of values, just to estimate things here. So we are saying the domain is restricted to values of x that are greater than 1. So greater than 1. So the derivative will start from 1 itself. So if you start from 1, you see that it will give you a 0 on the bottom, so it is not defined at that point. So if I try derivative 2, or let me say 1.5. So 1.5, if you substitute the 1.5 minus 1, it will give us 0.5. 0.5 into a 1, it's going to be 2 times. If I put a 2, 2 minus 1, what will be the answer? 2 minus 1 will be 1. Into 1 it will be 1. So 2 will give us a 1. If I put a 3, 3 on the bottom will give us a 2, so it will give us 1 over 2. So 1 over 2 is like 0.5. So we're now seeing what is happening to the graph. So if we were to sketch this graph, so this graph can never cut this line where we're saying its x should be greater than 1. So it cannot actually, it can never be equal to 1. So that becomes what we call the asymptote, the vertical asymptote at x is equal to 1. Now we've tried values like 1.5, and then we've tried 2, we've tried 3. So what have we observed? For 1.5, it has given us 2. So let's say 2 is there. 1.5 has given us a 2. And then for a 2, it has given us a 1. So let's say 1 is somewhere there. And then for a 3, it has given us a 0.5. So what are we saying? This is 1.5. That is 2, 3. So as we continue, we expect that the graph will be getting closer and closer to the x-axis, like that. But it shouldn't cut. And then that will continue going up as you get closer to 1. So in this case, we are saying that in terms of the values of y, we're getting closer to 0, and then we're also increasing towards the infinity. And then both are not part of the solution set. So that's a range. The reason being is we will not cut the x-axis, and then we shouldn't get to meet the asymptote. So continue going up. And that is true. As you've seen, as we are getting closer to 1, from reducing, we are seeing that the values of y are increasing. So if we are to get a number like, let's say, 1.1, and then ask yourself 1.1 minus 1, it will give you 0.1. 0.1 divided into 1, it will give you a 10. So values will continue increasing as you get closer to the asymptote line. So that is our range for that function. So is it a one-to-one function? Of course it is. So there's no way you can draw a line this function and then you expect that it will cut the graph twice. So it's a one-to-one function. So by the way, they didn't ask you to prove, so you can just state it is a one-to-one. And then for the last one, f of x is equal to 1 over x squared plus 1. How do we handle that one? So for that one, what we'll do is we'll do the same. Now here the domain is a set of real numbers. Now the moment I look at x squared, for me what comes to mind first of all is it is not possible for us to ever get a negative number in this case. So that's why the domain is actually a set of real numbers, because it is not possible that you can get a negative 1 to give you a 0 on the denominator because of the squared part or any even power. Okay, so that is a good starting point. Now the other thing that you need to think about such powers is it doesn't matter whether you're on the negative numbers or the positive numbers. These are the graphs that come out like this. Okay, now let's try to see this, how this one is going to come out. So come up with like a small we'll come up with a small domain, like a table of values, x, y, and then we'll use the values, let's say I'll use 2, -2, -1, 0, 1, and 2. So expect -1 and -1 on the opposite sides to give us the same result. So if I was to put a 0 on the denominator where there is x squared, I'll just have a 0 plus 1, which is a 1. 1 into 1 will give us a 1. And then if I put a -1 squared will be a 1 plus 1, 2. So 1 over 2, which is like 0.5. So expect the same for the other side. Now if you put a 2, 2 squared will be 4 plus 1, 5. So it will be 1 over 5. Now 1 over 5, if you know mathematics, it's 0.25. I believe it's 0.25. Yes. So yeah, pretty much that's where we are now. So if we were to sketch this graph, how is it going to come out? So we are seeing that the highest value so far we have is a 1, which is happening at 0, 1, 0, 1. And then after trying the other values like -1 and +1, they've given us 0.5, so which is like half, somewhere there. And then after trying out the other values 2, -2, again it is getting down and down. So what are we seeing in this function? So I'm seeing this function to behave like this, that being the highest point, and then to continue getting closer and closer to x. So already from the graph we're able to see that this function is not one-to-one, because if you draw a line, it will be able to cut the graph twice. So like we've seen actually from the table of values, two different values are able to give us the same value in the codomain. So that is not a one-to-one function. Now what can you say about the range? What can you say about the range? So of course if you try to find the range of that function, you notice that the graph actually, the line will not actually get to cut, it will not get to cut the, it's not possible. The reason why I'm saying it can't cut the x-axis is because we can't get a negative result in such a case. No matter what number you're going to put where there's x squared, you can't get a negative value, okay, because that is also positive. So the expected range is the highest value to be 1, and then all the values to be between 0 and 1. So 1 is part of the solution set, but I believe 0 will never be part of the solution set. So you can try to come up with the range of that function. You find that it will become something like a square root. Yeah, you can try to find the range.
So let us now talk about how to find the domain of a radical function and rational function. So we'll begin our discussion with the radical function. Any function that is in a square root, we call it a radical function. So now, how do we find the domain of a radical function? Let us try to understand something. Anything that is in the square root, we know that in the square root, if we have negative number, that is undefined. Definitely we know that if we have with f of x is equal to negative any number, that is undefined. We are trying to make the function to be defined, therefore the only thing that we can have in the square root, it is starting from 0 going to positive infinity. Therefore anything that is in the square root, just get the way it is. How do we find the domain? So you say domain, you underline, get what is in the square root only, x squared minus 4 greater than or equal to 0. So for x squared greater than or equal to 4. Initially let me just make things clear here. When I get the square root here, it's going to be x is greater than or equal to, I'm getting the square root this side and this side, then here to plus or minus, so it's plus or minus 4, plus or minus 2, sorry. Now one thing I want you to understand is that another person can come and say x squared minus 4 is the same as the difference of two squares, where you say this, because that is going to be the same as that. It's the same, greater than or equal to 0. It's probably the same. I shift this to the other side, x will be greater than or equal to 2, another one will be x greater than or equal to negative 2, which is the same with what I have here. So you choose what to do. Now what I'm going to do here is after finding these values, whenever we're talking about how to find the domain, when we're talking about the radical function, the square root, this square root, one thing you have to understand is that if you have got more than two values, it will always go back to inequality. So these are the critical values that I've found. So my critical values are x is equal to negative 2 and x is equal to 2. Then I have to come up with a table. Okay, I have to come up with a table. So this table, I'm going to have -2 here and 2. I believe, guys, you know about inequalities. So I'm going to put the number that is greater than 2, that is going to be 3. The number that is in between -2 and 2, I can choose any, but 0, -3. So what I'm going to do now is, if I shift this to the other side, it's going to be x plus 2. If I shift this to the other side, it's going to be x minus 2. Then the last column, you put in these two, like that. The next thing that you do, is now you start plugging in the values. So when you plug in -3 where there is x, it's going to be -3 plus 2, it is -1. So I'll just put negative. If I put negative here, it is going to be -3 minus 2, it is still negative. So negative times negative, it is positive. I circle it like that. If I put 0 here, it's going to give me what? If I put 0 there, it's going to give me +2. Again, if I put 0 here, it's going to be 0 minus 2, negative. So the overall is negative. Okay. Now let us look at 3. If I put 3 there, 3 plus 2, it is plus. 3 minus 2, it is 1, which is plus, again plus. The most important thing that I want you to understand is that the sign that we are dealing with, it is greater than. So if it is greater than, you get the part giving you positive. So this part and this part, and not this part. What does it mean? Any number from -2 included all the way to negative infinity, and any number from 2 all the way to positive infinity, but not numbers in between -2 and 2. So then the range, the domain in this case is going to be from negative infinity all the way to -2 union. Then I'll jump now. Okay, I'll jump there. I'll say, so -2 is included because we're dealing with greater than or equal to. So if we're dealing with greater than or equal to, that is included. So we'll say it is included union, again, 2 all the way to positive infinity. That is my domain. Based on this, I believe you can manage to solve part 2, which is B. Okay, it will be the same as long as you've got more than one solution. It's an inequality. Put it on the table, find the solution that is going to satisfy the function. So let's now do this one. So the domain is x squared plus 9 greater than or equal to 0. Let us look at that one now. So looking at how that question is, we can clearly see that if I shift that other one going to the other side, what's going to happen? What is going to happen here is that the way this question is, if I shift this, it's going to be greater than or equal to -9. You can't square a number and get a negative. There's a deal here. Let me show you something. You can't square a number and getting a negative, so this can't work. So I can't use this method. Once you notice that it is a radical function and it is failing to give you the x values, the only thing that has to come in your mind is that the domain is that any number that I'm going to put here from negative infinity all the way to positive infinity, that's the domain. I can put any number here, negative, positive, still is going to come out as positive in the square root, because if I square the negative, it will give me the positive. It's different from the first one because the first one there's a negative here. If I get any number, let's say I get -1, -1 squared is 1. 1 minus 4 is -3, which is undefined. But in this case, because there is positive in between, then any number can fit. So the domain is from negative infinity to positive infinity. Simple. Okay. Now I'll jump and also go to part E and F before I do C and F and D. So just get what is in the square root. 2x squared minus 5x minus 7 greater than or equal to 0. So for x, product is negative 14, sum is negative 5. We can clearly see that the factors will be negative 7 and positive 2. Okay, so that is going to be 2x squared minus 7x, okay, then plus 2x minus 7 greater than or equal to 0. We are solving for x. I've ignored this part and replaced with the factors. Let's now factor x. X will be equal to 2x minus 7. Here factor out 1, 2x minus 7 greater than or equal to 0. Then I've got x plus 1 and 2x minus 7 greater than or equal to 0. So for x, let's get rid of this. We are solving for x. X plus 1 greater than or equal to 0 and 2x minus 7 greater than or equal to 0. So x will be greater than or equal to negative 1. Then here it will be 2x greater than or equal to negative 7 or positive 7, not negative 7. Divided by 2, divided by 2. X is greater than or equal to 7 over 2. Now let us look at something here. Now we have got, like I said, we have got more than 2 solutions. So then you say critical values. So what is happening here now is we have x is equal to -1 and x is equal to 7 over 2. So what do we have? But remember, we still have these are the things I'm going to use when putting them on the in the table. So I'll do this. I have this. So now the number that is the least number has to be here, that is 7 over 2. No, it's supposed to be the opposite. It starts from this line, or -1, then 7 over 2. The number that is greater than 7 over 2, we know that 7 over 2 is 3 point something. Just put 4 or 5, it's fine. Then here I'm going to put the number which is between negative and positive, just put 0. Here I'll put -2. Then you write now these x plus 1, 2x minus 7. Then here you put these 2. Then now when you do this, now you start now plugging in the values. -2 into x plus 1. So it will be -2 plus 1, which is negative. There is going to be -4, still negative. Overall positive. Negative times negative is positive. 0 there is going to be plus. 0 here is going to be negative. Overall will be negative. If I put 5 there, it will be positive. 5 here positive. Then this is going to be positive. Remember, we are dealing with positive here. We are dealing with greater than or equal to. Therefore, this is my answer and not this. So then the domain is starting from negative infinity to -1 union, but -1 is included because it is greater than or equal to union, again starting from 7 over 2 all the way to positive infinity, like that. That's my domain. You do the same for part F. Try to do part F. Type the answer in the comment section. I'll be able to check it out and I'll tell you if at all the answer is correct that we're going to find. Okay, now let us do part C, which is the rational function. How do we find the domain of a rational function? You can never have a situation where f of x is equal to a number over 0. If that's the case, you can't have 0 over 0 at the same time. If that's the case, then we say just get the denominator, set it not equal to 0. Solve for x. In a case of the first one, the domain will be get the denominator set it not equal to 0. So for x, what is the product? Product negative 16, sum negative 2. What are the factors? Not negative 16. Where are we getting negative 16 from? The product is negative 8. Okay, we are doing A times C. So 1 times negative 8 is negative 8. Sum is negative 2. Factors, what factors do we have? So let us see. It should be 4 and 2. So negative 4 and plus 2. Negative 4 times 2, positive 2 is the negative 8. Negative 4 plus 2, negative 2. So then we are going to have, I'll continue from here. X squared, ignore negative 2, then now focus on this, replace it with that, not equal to 0. Then factor out x, x minus 4, factor out negative 2, x minus 4, not equal to 0. So then x plus 2 and x minus 2 should not be equal to 0. Therefore x should not be equal to negative 2 and x should not be equal to 4. What does it mean? The domain is telling us the only number that we are not supposed to include is negative 2 and 4. But any number is going to fit. So the domain will be from negative infinity all the way to negative 2, not included, union, again from negative 2 all the way to 4, 4 not included, union, again from 4 not included all the way to positive infinity. That is my domain. That is something that is not complicated, but you are supposed to know it. It's something that is very simple, guys. Let us look at the last one. Let us look at the last one. So the last one is saying just get the denominator, x to the power 3 minus 16x not equal to 0. Here I can do direct thing. Factor out x. You remain with x squared minus 16 not equal to 0. What does it tells you? It tells us that x should not be equal to 0 and x squared minus 16 should not be equal to 0. Then this is a difference of two squares. Then it can be written as x minus 4 and x plus 4 should not be equal to 0. Or if you want, you can shift 16 to the other side. You're going to get the square root, so it's going to be plus or minus. So x will be not equal to 4 and x will be not equal to negative 4. Now how do we write the domain? Now we have got a lot of values. Let's see. So the domain will start from negative infinity all the way to the negative number, which is negative 4. Cross. It is not included, that one is just open. Union. Again, it has to start from the same number all the way to the next number is 0. Cross. Again, what is the next number? The next number again from 0 itself all the way to the last number, that is 4. Again, I have to say union. I jump again from what? From 4 all the way to positive infinity not included. That is my domain. Does that make sense? Yes, it does. Yes, it does. So I had to factor out x, like we said. Yeah, so that is my domain. That is my domain. So that's how we find the domain of a rational function and radical function. Okay. So in this tutorial, I want us just to focus on how to find the domain and range. So I've selected these questions that I want us to do, guys. So the first one is saying find the range of each of the following. Not the domain, but the range. Okay, so we're interested on how we can find the range. I'm going to explain about the domain later on, but for now let's focus on the range. If at all I've got a graph, I'll give an example. The graph is like this. The domain in this case we focus on the x values. These are x values. and these are y values. The domain we're looking at where the graph is going in x. We can clearly see that it's just going there, it's going there. So it is from negative infinity to positive infinity using the graph. And the domain of any linear function like this one here, it is from negative infinity to positive infinity, or we say all real numbers. Or the number that I can put here is going to make the function to be defined. But what of the range? The range, we're talking about the y values, okay? Now, the y values, you look at the graph. Where is this graph starting from? So let's assume that this point, it is positive 2. The graph is starting from 2, but it is going all the way to positive or to negative infinity this side. So then we start with negative infinity to 2. Is 2 included? Yes, so I will say like this. That is included because at that point the graph is passing there. Okay, now I've given you the overview on how to find the range. Let us now look at the first question. Now I want you to understand one thing. Whenever you're talking about linear function, or when you want to sketch the linear function, we look at what we call, it is in a form of f of x is equal to ax squared plus bx plus c. So mostly we look at a. If a is greater than, let me start with less than a, the graph is going to curve like that. If a is greater than 0, the graph will curve like that. Now this is what is going to tell you how the domain is going to be, sorry, how the range is going to be. So you focus on a. Let us look at the first one. The first one here, it is saying as x squared, that is a. Now a, it is positive. So if a is positive, the graph has to curve like that. If the graph has to curve like that, the last number here, the curve, if this is the graph here, let me first do this. If this is my graph, the number where the graph is going to be, we look at this number which doesn't have x. The number that doesn't have x in this case is 7. So 7, I will say maybe 7 is here. This graph, it has to cut somewhere like this. I use this, it will be like that. It will cut on 7. It goes like that. Okay? But forget about the graph for now. This graph, I just want to show you how it's going to look like. So it is starting from 7, positive 7, all the way going upside. So the range in this case, it is 7 is included. So 7 to positive infinity not included. That is the range. So the key part is, look at x squared. Is a positive or negative? Then get the nature of the graph. Don't sketch, but just look. Is it going to go upside down or upside? Is it going to go up or down? Then now look at the number which doesn't have x. So for example, let us look at now the second part. This second part here, if we can clearly see here, guys, it is telling us to say we have 16 x. Now in this case, a is, this is, now a is what? Negative 1. So it is negative. What does it tell us? It tells us that if it is negative, it's going to curve like that. Now it's going to positive infinity. Now we look at the number which doesn't have x. This is the number which doesn't have x, meaning that it is actually from 16, from positive 16 to negative infinity, but we start with the negative side. So it is negative infinity all the way to 16. 16 at that point is going to be included. So it's like this. This is 16. The graph will curve like that. But we're not interested in the graph. We just want to find the range. So that's basically how we find the range of a linear function. So now I will go direct to part E before I go to part C and D. If we look at this question clearly, okay, how can I find the range? Look at it, guys. Just clear. Just look at it. Okay, so we are now solving E. Let us look at E. You look at the number. Now this one is going to be different. Okay, this one is going to be different. How is it going to be different? Let us see the different which is going to be there, because here I've got these ones. I was considering that because I didn't have any number that has just x. Now in this case, it is 3. It it is 3x squared minus 6x plus 12. So I can't say I'm going to get that number. In that case, I can't say that. Okay? So what's the best way on how we can find actually the range of what? Part E. The best thing that we can do, guys, is let us first go ahead and identify A. Okay? So A is actually greater than what? Greater than 0. What tells us? The graph is going to curve like that. After knowing that the graph is going to curve like that, then we have to find what we call the minimum value. Okay? So where is the minimum value going to be? If I find the minimum value, that minimum value, I'm going to, what I mean is the minimum value, it is the point where the graph has to turn. Okay, does that make sense? So what I'm going to do is to find the minimum value, we use this formula. We'll say x is equal to negative b divided by what? Divided by 2m. So what is b? Is negative 6. So negative will cancel, have 6, 2, then 3. That gives me what? That gives me 6 over 6. So it's going to give me 1. That it means that x is equal to 1. So now when x is equal to 1, let's find the value of y. So we're trying to find now the value of what? Of y. So we have this. What are we going to have? When x is 1, the value of y is where is it? We're finding the minimum value. That is going to be 3, 6 plus that. So that is going to be negative 3. Or we can start with this. That's 5. Okay? Yeah, it's 5. 5 plus 3 is 8. So f of 1 is 8. So now this one, why am I doing this? Because I have got a number that has got just x and not x squared. These ones I was doing direct because it was just direct. Okay? So this one I have to find the minimum value. This minimum value is the one you are going to follow now. Since it is positive and the graph is going to curve like that, what comes in your mind? It is the range starts from 80, from the minimum value, all the way to positive infinity. What has helped me to find here is the minimum value, which is 8. Okay? Then, since it is greater, a is greater than 0, then the graph is going to curve like what? It's going to curve like that. So it's going to positive infinity. So that's why it's 8 to positive infinity. Using the same concept, let's go ahead and find for part F. So, part F, first of all, let's identify a is what? Less than 0, because it is negative 2. What comes in our mind? The graph is going to curve like that. So what should come in our mind is that it will go all the way to negative infinity. But we don't know the minimum value. In that case, we call not the, if the graph, if you have got a less than 0, we have got what we call the maximum value. If you have got a less than greater than 0, we have got the minimum value. That's why I was finding the minimum value. So in this case, we are going to find what we call the maximum value, but the formula is the same. So x is equal to negative b divided by 2a. So negative, it will be negative 8 to negative 2. So it will be negative 8 over positive or negative 2, 4. So the answer is what? 2. What comes in our mind? Let us see. Okay. After finding x, this is the value of x. Now I'll go ahead and plug in the values. So I'll say f of 2 is equal to negative 2, where there is x, we put now 2, this value, plus 8, then 2 minus 9. So this is going to be 4, negative 8 plus 16 minus 9. This and this is going to give me 8. 8 minus 1 is negative 1. What does it tell me? So the graph now, we already know that it is a maximum, so it is like this. It will go all the way to negative infinity. The number that is going to start with, it is the number that we have found after plugging in the value. Does that make sense? So that means that it is from negative infinity to negative 1, but negative 1 included, this not included. That is the range. If I want, I can go back the same method I was using for finding the minimum and the maximum. Even part A and part B, it can also still work, only that this question is the same as f of x is equal to x squared plus 0x plus 7. So it will be x is equal to negative b over 2m. B is 0. Any number divided by 0 is c. So that's why we don't consider using this formula, because it will still give me 0. Okay. So that is it for linear function. Now let us focus on the rational function. This is what we call the rational function. To find the domain of a or the range of the rational function, there are two ways. I'm going to show you two ways. The first one, you can either find the inverse of the function. So let us find the inverse of the function. The inverse of the function is going to be, we replace that with y, 2 3x minus 4. I divide there by 1. Let's make x as a subject of formula. 3xy minus 4y is equal to 2. What else? 3xy is equal to 2 plus 4. I'll divide both sides by 3x, so it's 3y. I'll divide both sides by 3y, even here 3y, here there is y. Therefore x is equal to 2 plus 4y divided by 3y. So you focus on the denominator. Set the denominator not equal to 0. 3y should not be equal to 0. Okay. Then make y as a subject of formula divided by 3 by 3. Y should not be equal to 0 over 3 is 0. What does it mean? It means that the range, you can even put it inside Boolean notation. Range, you can say y is such that y is not equal to 0 and y is a member of all real numbers. Or you can say the range starting from negative infinity all the way to 0, but 0 should not be included, union from 0 to positive infinity, meaning 0 is not part of it. That's why it is not closed. Okay, that's the range. Another method that I'm going to show you is a very simple method. There's what we call, there are only two principles. If at all the function is bottom heavy. What do I mean when I say the function is bottom heavy? The denominator or the degree of x on the denominator is higher than the degree of x on the numerator. We can clearly see that this is 3x. On top we don't have any x. If that's the case, then y should not be equal to 0, direct. Then you say range negative infinity to 0. It's the same thing, union 0 to positive infinity. You can either use set Boolean notation, that's okay. Okay. Now, what if the numerator and the denominator have got the same degree of x? For example, the part D. If they have got the same degree of x, you say y is not equal to, you divide x divided by 2x. So you divide in short we say divide the coefficient of those things. But it's the same thing because x and x will cancel out. Therefore y will be equal to x and x will cancel out, it will be 1 over 2. So the range is now y is such that y should not be equal to 1 over 2, comma y is a member of all real numbers. Another thing I can say, the range is from negative infinity to 1 over 2, union 1 over 2 to positive infinity. That's the range. So there are only two principles. The function is bottom heavy, the y value is not equal to 0. Another principle is that when the denominator and the numerator have got the same degree of power, like the same degrees of x powers, then we divide the coefficient. In this case I've divided x over 2x. X and x will go, so 1 over 2. That is it for question 4, and that's how we find the range of linear function and rational function. Yeah. So let's now talk about question 5. So the question 5 is saying if f of x is equal to 2x squared minus 3x plus 1 and g of x is equal to 3x plus 1, then h of x is equal to the square root of x squared minus 4x. Find the first one is f of g of x. What does it mean? In the function of f, where there is x, put g. That's what it means. So in this function, so we say f of g of x. In the function of x, in the function of f, where there is x, we put g. So 2, where there is x, now we put g. G is 3x plus 1 minus 3 again, where there is, so this is squared, don't forget. Then this one will also be 3x plus 1, like that. We can now simplify this. We know that when we have something like this, guys, squared, it's the same as writing this twice. So it is 3x times 3x, it is 6 or 9x squared. 3x times 1, 3x, 1 times 3x, 3x, 1 times 1, 1. Then this one will be direct. 3 negative 3 times that one, it will be 9x minus 3. Then now I can distribute this, but before I distribute 2, let us first simplify this. 9x squared plus 3x and 3x is 6x plus 1 minus this, that. Now we can distribute 2. 2 times 9, it is 18x squared. Plus that is going to be 12, because 2 times 6 is 12x, then plus 2 times 1 is 2, minus 9x minus 3. Write them together. This, which one? This and this can be added, this and that can be added. So it will be 18x squared, 12x minus that, it should be 4. 4 or 3 is 3x. 2 minus that, negative 1. I'll go through again to make sure that I have not made any mistake. So I'll go through again to make sure that I have not made any mistake. So let us see. Let us see what we have done. But now here, have you seen, guys, where there is x, but again here there is plus 1, so I've forgotten plus 1 here. I'm supposed to put plus 1 here, plus 1 there, plus 1. So what does it mean? This one is more like, now I'm adding 2, and this is negative 3 minus, or negative 3, that is going to give me negative 1 plus 1, 0. So I'm not supposed to do this. So make sure you always check your work, because as you can see, I made a mistake here. So the answer is 18x squared minus or plus 3x. That is the answer. Okay. Now let us go ahead and do part B. Now part B, they are giving us the same thing. Now they are saying that where there is x, put now 2. That's what they're telling us. The same answer we have found. So we have found that f of g of x is 18x squared plus 3x. So now they want us to find f of g of negative 2. Where there is x, put negative 2. I'll square it, plus 3 negative 2, like that. So I can get rid of this. Then we'll have, that is going to be 4. So 18 times 4. What is 18 times 4? So we just do 18 times 2. That is 36. 36 times 2. That should be 72. So 4 times 18 should be 72. Yeah. So it will be 72. Negative has been cancelled out, because when you square anything negative, it's going to come out as positive. Then it will be minus 3. So 72 minus 6, that is 66. So that should be the answer for that question. Now let us go to C. Part C is telling us to say, find G. We want to find G of what? of f, now the opposite of what we were doing. So in the function of g, where there is x, we put f. That's what they want. So 3, where there is x, we put now 2x squared minus 3x plus 1, then plus 1. So this is going to be direct. 3 times this is going to be 6x squared minus 3 times 3 is 9x, then plus 3 plus 1. So these two can be added. That is going to give me 4. So it's 6x squared minus 9x plus 4. I'll go back and check if at all I've made any mistake, so that at least things should be better. Okay, so let's see the answer that we have found. So the answer that I've found is we're finding C, right? So we are saying in G, where there is x, we put f. So I have put 2x squared, yes. So I've put 2x squared minus 3x plus 1. Then outside there is also plus 1. So remember, there is 3 outside. Okay, cool. That answer is correct. That answer is correct. Now we can go to part D. So part D is telling us to find h of g. Let us see f of g, h of g. So in the function of h, where there is x, we put g. So it will be h of this. Then again we are going to put 3. So where there is x, we put g. So g is 3 plus 1. So I have to square it, minus 4. Again I put in 3 plus 1. 3x, right? So it's 3x plus 1, like that. So then I can clearly see that I can now expand that other one. And what do we expect to have? 3x squared is 9x squared. 3x times 1, 3x. 3x times 3x, or 3x times 1 times 3x again is 3x. 1 times 1 is 1. So here it will be minus. That is going to be 12x minus 4. Let's see. So now these two can be added. That is going to be 6. But 6, there is minus 12 here, so it will be negative 6. So I'll write 9x squared. This is going to give me negative 6x. But again, this guy and this guy can be added. That is going to give me what? Negative 3. So now they're telling us that where there is x now, after finding that, where there's x now, we plug in what? We put 3. That's what they want us to find. So it will be 9, 3 squared minus 6 times 3 minus 3. So then it will be 9 times 9 is 81, minus 3 times that is 18 minus 3. So now we have 81 minus 18. We can just say 81 minus 21. Okay, 81 minus 21. That is going to be 60. But this 60, the square root of 60, I don't know, but I can make things simple. Okay. So how can I make things simple? I can now say 2 goes there how many times? Or which one should I use? Should I use 4 4 into 60, 15. So I can say root of 4 times root of 15. So that will be 2 root 15. That's the answer. But if you want, you can leave it there. It's fine. So try to check if at all I've made any mistake, and then try to correct the mistake that I've made. Okay. So what else do we have now? What else do we have? What else do we have? So we go now to part D. So part D is saying f of g. Oh, so I started, oh no, B I have already solved. Then I've not solved D. You have seen what I've done. I've solved, hey, I've solved D, A, B, C, then I've gone to E. So meaning that this one I've solved as well. What do I mean? Before I plugged in X, that answer which I said h of this, before I plugged in the values, it was 9x squared minus 6x minus 3. That was the answer for part F. Then E is the one which we have found now here. That is for E, if you have seen it properly there. So part E is just that answer that I've found. Then for F, where is F? Yeah, for F is 9x squared minus 6x minus 3. So if you plug in the values for part E, you'll find that. Then for part E, now the one which I have not solved is D. Let's solve D. But try now to pause the video and try to check the answer that I'm going to find for you. So let's do now D. F of h. So f of h of x, in the function of f, where there is x we put h. So now that is going to be 2, where there is x we put this x squared minus 4x, then minus 3, but this has to be squared, let's not forget that. Then 3, then again root x squared minus 4x plus 1. So it will be the square root, and that will cancel out. We'll have this, then minus 3 root x squared minus 4x plus 1. What else do we need to know? 2 times x squared is 2x squared, so it will be minus 8x minus 3 root x squared minus 4x plus 1. What else do we need to do? I can clearly see that. Do we have any like term together? No, we do not have. So I can end there. That's my answer. So that is it for question 5.